the geometric cabinet, and it's one of the most key materials for the study of geometry, particularly in the early years of the middle primary cycle. The children who have been in the junior primary classroom have seen this material before, and they've explored it in a sensorial manner. We are now looking more at the etymology behind the names of the shapes. We are looking at the properties of the shapes, how to quantify them, how to organise them. Geometric cabinet starts with the presentation tray or demonstration tray, and it is made up of the triangle, the circle and the square. And in this material we begin by not only naming it, the children know those names, but giving the etymology behind where the word circle, triangle and square come from. And they're getting to use those skills that they were introduced to in junior primary, the clear even strokes that they might have recognised from the metal insets. Following on from that, there are 6 other trays, and the first tray that they really begin to explore is called the polygons tray. And within the polygons tray, they have polygons from 5-sided to 10-sided, and we will often take from the presentation tray and bring in the square and the triangle to represent the 3-sided and the 4-sided polygon. Now this is a piece of information that is very key to have right at the start, and we really focus on the meaning behind the words. So the word polygons, as the children come to know, comes from 2 Greek words, poly and gonia, and poly meaning many and gonia meaning angles. And then we begin to explore how each name actually tells us how many angles are in the shape. So we look at tri meaning 3 and angle meaning angle. And then for the pentagon, the hexagon, the heptagon, the octagon, the nonagon and the decagon, they have that Greek heritage of the gonia. After a bit of exploration of the polygons, we classify them as regular. What does that mean? And that will be developed on a lot more later on. Then we begin to explore the other trays. So first of all, we will look at the circles, and we will first just order them from smallest to largest. We look at the meaning. What does the meaning of circle mean? It actually comes from a word meaning ring, and it could be a ring of any size. So we like to describe it as the ring, small as the ring around the finger, or as large as the ring around Saturn. It opens up a lot of conversation. So we're ordering it in size. First, in many of the geometry lessons, they trace, and then quite often in the second presentation, they will cut and paste. So they're getting to practice the concept twice. The lesson might happen 3 or 4 times depending on the challenge of the concept. Then we actually bring the polygons and the circles together, and they explore sort of the relationship between the number of sides and how as they get larger, the space within the circle becomes smaller. Then they're introduced to the rectangles tray. Again, it's very similar to the circles tray. It has rectangles ranging from the narrowest to the widest. And as you can see, the last one is a square. And we point out at this point, the meaning of rectangle comes from the word recto meaning right. So we talk about how they have right angles. So we can classify square as a rectangle, but we say that all squares are rectangles, but not all rectangles are squares. And that's something that we take forward into our study of quadrilaterals. So again, the children have traced the rectangles, but then we bring the 2 trays together, the circles and the rectangles, and explore that sensorial element to them. And then we do the same with the squares, just the square. So you can see as the diameter of the circle gets wider, it takes up more and more space of the square. Then, which is one of my favourite parts, we explore the quadrilaterals. Now, from the initial introduction to the polygons, the children are aware that the word quadrilateral refers to a four-sided shape. They have now explored the square and the rectangle, and now we look at the other quadrilaterals. So this part is not just naming, we're really looking at what quantifies a shape as a parallelogram, what makes it a trapezium. We're still providing that etymology, that story behind the words. So the trapezium comes from a Greek word, trapeza, and that means table. So we look out to our benches outside where it has a shaped leg that looks like a trapezium, and that's where it gets its name. So we go through all of that. With a lot of these materials, we have nomenclature cards. So we have the pictures, and then we have the labels. So we find the appropriate label that matches. So we have the trapezium, the card, and then we have correction cards if needed, but by this age, because we're introducing them one at a time, they don't often need it, but if they do, we do have the correction card, and there is a definition to go with it. Because, as I said, it's really important that we're starting to quantify and understand what is a trapezium. It has one pair of parallel sides, whereas what they'll learn is a parallelogram has two parallel sides, and that the rhombus is a special type of parallelogram. So we're really exploring this. The sort of work that they would do following up lessons on this is they would be tracing, they'd be labeling, they'd be defining the different parallelograms. And then following on from that, they will do the cut and paste. So that's really that final stage where they're practicing those skills that they've learnt, and this might take 4 or 5 lessons to build up this knowledge, and it's something that we continue to revisit throughout the cycle. And then we move on to the curved figures. So the curved figures is this tray, and quite often we bring the circle in as well to this tray because it is the curved figure that everyone knows. And again, it's about the terminology. So the part of the lesson might be to boil an egg and cut the egg to show that the oval is actually egg shape, and the word oval comes from ovum, meaning egg. And then the word ellipse, when we put it inside the outline of the triangle, it means something is missing because there's a space around the edge. Quatrefoil, quatre meaning 4, and it's 4 leaves. So we really talk about the names behind it, but what's interesting with this material is that we use it to explore the idea of symmetry. So this is when we're defining what symmetry means. The children then explore the material by folding the paper over to find the lines of symmetry. And what they find is that they can't actually stop folding the circle. It has an infinite number of lines of symmetry. And then, which another teacher will go into more detail about, they use the materials to also explore the triangles, so the 7 triangles of reality. At this stage, they're really learning to name and identify and learn the properties of the different shapes. This will then lead on to their further study of the parts of these shapes, finding area, perimeter, and they'll be able to do different classifications, use this when they're exploring the geometric solids to look at the types of faces they might have. So this is really the foundation of the middle primary geometry curriculum.
Today I'm going to present 3 lessons that we do about triangles. In junior primary, the children are introduced to the basic concept of a triangle is a 2-dimensional shape with 3 points. In their polygon lessons, they are then introduced to the word polygon, which means many angles. This is our basic first many-angled shape with 3 angles. The children then advance to discover that there are different types of triangles in their environment. The basic triangle that we learn is the equilateral triangle. The equilateral triangle has 3 equal sides. The second triangle that they learn is the isosceles triangle. As part of the Montessori curriculum, we also teach them etymology, which is the meaning behind words. The isosceles triangle comes from the Greek iso, meaning equal, celes, meaning legs. This is a triangle with 2 equal legs, a little like our own legs if we stand up. This is an isosceles triangle. The next triangle that we introduce to them is the scalene. The scalene triangle comes from the Greek. It has 3 unequal sides. Scalene comes from the Greek meaning ladder, and it was from the shape of the ladders leaning against a tree that they got the name. And that is the first lesson that they are introduced to. The second lesson they are introduced to in middle primary is identifying triangles by angles. Now, they go back and label their triangles that they know: the scalene, the isosceles, and the equilateral. They then learn about the 3 basic angles: the acute angle, the right angle, and the obtuse angle. The children then sort the triangle tray and they have a look for obtuse angles, acute angles, and right angles, and then they sort accordingly. The equilateral triangle has acute angles. This isosceles has an acute angle. This scalene has an obtuse angle. This triangle has a right angle. This triangle has a right angle. This triangle has an obtuse angle. And this triangle has acute angles. Once they have mastered identifying triangles by angles, we then introduce them to the 7 triangles of reality, which allows us to create a table. We have obtuse angle triangles, right angle triangles, and acute angle triangles. We have our equilateral triangle, our scalene triangle, and our isosceles triangle. Knowing that these are our acute angles, we now sort these triangles according to their name. This is an acute isosceles. This is a scalene, acute angled scalene, and this is our equilateral triangle, which will always have 3 acute angles. Later on, they will learn why there are the angles are classified that way. These are our obtuse angles. This is a isosceles. This is our obtuse angled scalene. this is a right angle triangle, and it is an isosceles triangle, and this is an acute angled scalene. The children then go ahead and classify these into a chart and are able to recognize the different triangles in their environment.
So now we're going to focus on the rectangle box, which is the second of 6 constructive triangle boxes with the Montessori Visual Sense Central works. And you can see that the second box is a part of a set. Normally the children have been using those boxes in junior primary. So with this box, the child will continue to work on focus and concentration and move into math concepts. In junior primary, they had the chance to feel and experience the shapes. Now we will focus on naming the shapes and analyze the properties. For that, the child will make connection between the different boxes of the geometry cabinet. So using this box again, they will also have the chance to see that all plane figures constructed with straight lines are composed of triangles. They will help for the preparation of understanding the concept of equivalence and its application for finding the area of place figures. To help us, the control of error in this lesson will be the black lines in each shape. So we can see the black lines in each shapes of the box. So we can sort all the triangles we've been displaying on the table by shapes and then by color. So we can begin with 4 right angle isosceles triangles. So we have 2 green and 2 yellow. Then we have 2 yellow equilateral triangles. Then we can find 2 green and gray. And yellow. Right angle scalene triangles. 1 right angle scalene triangle. And 1 red obtuse angle scalene triangle. At this stage, we could ask the child which stack we would like to put together to see what shape that can make. So if, for example, we would like to work with this pile, we could use the green triangle, slide them, and trace with a black line, put the shape together. We can offer the child to have a turn to make the shape and discover what is this shape. And for this example, we can obtain a square. If we're using other piles, and again, putting the black lines together, here, we can obtain different other shapes, like parallelogram, for example. We can obtain here a rectangle. Or a rhombus. And if we use the red shapes, together, we can also obtain the trapezium. So when we finish with all the shape, we can really work with the child to focus on the naming all the shapes, work through them and name each shape for review, and give the child the chance to play with the shapes and make the shapes. In conclusion, we would like to focus at this stage that all the parallelogram are types of quadrilaterals, and they all have, as we can see here, parallel lines at some stage. So that's why we want to focus. So young children can begin to explore this area early in their learning, and they can progress through the boxes on the time.
In junior primary, the children will have been introduced to the geometric solids and might have worked on learning the names of these geometric solids. This lesson revisits the geometric solids and helps the children learn more about the properties of these solids. This is an adult-based version of the lesson that is presented to the children. Geometric solids. Non-rolling, rolling. Rolling. Non-rolling. Non-rolling. Rolling. Rolling. Non-rolling. Non-rolling. Rolling. Rolling. Non-rolling. This rolling solid, shaped like a footy ball, is called an ellipsoid. This rolling solid is called a cylinder. This egg-shaped rolling solid is called an ovoid. This ball-shaped rolling solid is called a sphere. This one, shaped like an ice cream cone, is called a cone. This group of non-rolling solids are called prisms. This group of non-rolling solids are called pyramids. They are shaped like the pyramids of Egypt. This prism with triangles on both ends is called a triangular based prism. This prism with squares on both ends is called a square based prism. This prism, shaped like a sugar cube, is called a cube. This pyramid with a square on the bottom is called a square based pyramid. This pyramid with a triangle on the bottom is called a triangular based pyramid. These are the geometric solids. The children will practice the use of these solids independently, and then they might do follow-on lessons which look like this. The children might hunt in their environments for everyday objects that have the same or almost the same shape as these geometric solids. They might make a record of their findings like this. In their maths workbooks, when the children encounter questions about the properties of three-dimensional objects, such as the number of faces, vertices or edges, if necessary, they might obtain the object from the shelf and use it in a tactile manner to count the faces. In this case, they are looking for the corners of a square-based pyramid. 1, 2, 3, 4, 5. When working on the faces of these objects, the children might use the object to trace around like this. This clearly shows them that this triangular prism has 3 rectangular faces and 2 triangular ones. They might use this net to make the triangular prism. The children work on jobs such as making geometric models, where they make the model and record its properties in their book, on their books. The children could also engage in jobs like this, where they use wooden sticks and Play-Doh to make 3D objects.
Today I'm showing you a version of these geometric lessons. It is slower and involves discussion when done with the children. The children have been introduced to the names of geometric shapes and solids. And then we start with the story of geometry, which is set in Greece. And then we start introducing the fundamental concepts: solid, surface, line and point. So to introduce the concept of solid, we use everyday materials. So there's a box and there's a ball. Can this ball occupy the same space as that box? No, it can't. So solids occupies space, and 2 solids cannot occupy the same space at the same time. Then we move on to surface. The ball occupies less space than the box. That determines the space of each object, and it's the surface that determines the space an object occupies. Then we introduce the surface. So this tissue paper, it has got only 2 sides, so it's a 2D shape, unlike this ball and the box that has 3 sides. It's 3-dimensional. When they're introduced to the line, we also give them a tactile way to see a line. So this is a line and it goes indefinite. It's indefinite. There's no end to this line. But there's always a starting point, and then we introduce the children to a point with a sharp pencil, make a small dot. And in reality, this dot that we have made, I usually ask the children to make the smallest dot with their sharpest pencil, and then explain to them that in reality that dot is much bigger than the real dot, and this line is also much thicker than the real line. Then we look at the 2D shapes. So what kind of line does this have? Where is the beginning of this circle? What kind of lines does this shape have? And does it have a beginning? And does it have an end? Then we move on to the types of lines. So there is a straight line, and that's a curved line. Then we move on to the parts of line. So this is a line. It goes on indefinitely, but it has a starting point, and that is called the origin. And that's why the line has an arrow on one side and one side a dot, and that is called a ray, because it goes on indefinitely on one side, and on one side it's just the starting point. Then the children do a little activity where they hold the line, and then one child cuts at these points, that's been marked, and this is what they get. So then they realize that this is just a part of that whole big line, and now it's got two ends. So these are the end points of a line. During all these lessons, we stop and look, and the children are looking around in their environment to find real life examples of all these concepts. Then we introduce the positions of a straight line. So I usually start with this. So this is a horizontal line. This is a vertical line. And then when we swing it, what happens to the line? It's an oblique line. And then we move on to more different position of the lines. So they use these geometry sticks to make the lines, consecutive lines, adjacent lines. So this gives a very clear picture. Parallel lines, so we use two figurines to show that they are together but they will never meet. Convergent lines, they are together, and as they keep moving forward they go away from each other. That is divergent. And the same way, they start from far away and then they meet, so that's convergent. Intersecting lines where they cross each other and they have one starting point, so they start from one point and then they move away from each other. And finally, perpendicular lines where we use a protractor to measure the angles and see that each angle is 90 degrees.